Hello everyone, in our Datathon 4, me and my teammates Ahmed, Irene, Jericho, Maria and Nisha analyzed the breast cancer dataset, which we will show our findings shortly. Our dataset is from UCI Machine Learning Repository, contains 32 features and the medical information for 569 patients, classifying the type of tumor into malignant or benign. The features are different characteristics from digitalized image of breast mass. Our objectives are first showing correlation heat map for all the variables, the number of PCs which explain the most variance, hierarchical clustering performance on our data, optimal clusters in k-means, how clustering differs with k-means or hierarchical, and lastly we will show an example of using some selected features from data to detect the patterns or groups in breast cancer. Here you can see our correlation heat map that there is strong positive correlation between different variables such as perimeter mean with radius mean or area mean with perimeter mean. Now Irene will explain about the second objective.
Moving on to objective 2, we applied principal component analysis to explore patterns in cell nucleus characteristics. So PCA basically transformed the data to a lower dimensional space while retaining most of the variability present in the original data. The heat map represents the correlation between the original features and the principal components. So each row represents a feature from the original data set and each column represents a principal component. So for example, looking at the first row, radius mean, we see positive values for PC1 and negative values for PC2 and PC3. This suggests that radius mean has a positive correlation with PC1 and a negative correlation with PC2 and PC3. The bar chart shows percentages of explained variances for the principal components. So PC1 explains 60.89% of the variance, while PC2 explains 26.1% of the variance, and lastly, PC3 explains 12.99% of the variance.
For our third objective, we wanted to look at how hierarchical clustering performs on our data. The columns that were used were the main variables that reflect characteristics of a cell nuclei for patients with breast cancer. So this includes things like radius of the cell, perimeter area, and concavity. For the distance metric, we used the Euclidean distance, which measures the straightest line between two different data points. And the award linkage function was used to minimize the overall variance when forming clusters. And this may be the best because all of our values were numerical. Lastly, for the threshold and decision for the number of clusters, we can look at the stems or the lines on the dendrogram to decide that 2 would be the most ideal for this data. All the lines that are connected indicate some common similarity since we are clustering based on a hierarchy. And the scatter plot on the right shows this more effectively and segregates the two main clusters in a more clear manner.
We also implemented k-means as a way to cluster the data based on PC1 and PC2. We explicitly defined a K of 2 based on our classification of being benign or malignant on a patient. But to confirm the appropriate K, we verified this using the elbow method, which indeed confirms that 2 clusters appears to be the most appropriate.
Our fifth objective is to understand what is the difference between the hierarchy clustering and the k-means clustering that we have applied to the dataset. As we have clustered using both, we see that majority of the data points are grouped into similar clusters by both methods, but there are some differences in some points. Let's dive into the main reasons and the differences between the hierarchical clustering and the k-means clustering. The algorithm type that we used in a hierarchical clustering is based on a bottom-up approach. The one that we have used is agglomeratic clustering, whereas in k-means clustering we use a centroid based or a partitioning method that divides data into k non-overlapping subsets. Sensitivity to outliers is another reason, wherein the hierarchical clustering can be more sensitive to outliers compared to k-means. The computational complexity is the third reason, wherein generally the hierarchical clustering is more computationally more expensive than the k-means, especially for the large data sets. Over to Nisha.
Moving on to the last objective of the project, which is feature analysis. Here we will be delving into the question, is it possible to detect distinct patterns or groups in breast cancer data using features like radius and texture? Here we have applied principal component analysis to reduce the dimensionality of the data to 2 dimensions, and using k-means clustering elbow method we determined that the best number of clusters for our data was 2. Here we see the scatterplot visualization that vividly shows how the k-means algorithm effectively grouped our data into distinct clusters. We can see 2 clear groups, one colored blue for benign type cancer, another green for malignant type cancer. Here, as we observe the plots, we can easily distinguish between benign and malignant tumors based on the spatial arrangement in the plot. Within each cluster, only radius and texture features were used for analysis. The similarity in feature space contributes to the tight grouping observed, indicating that the tumors within the same cluster have common characteristics.
In terms of future direction, we've highlighted 3 main points. The first is to implement a predictive model, where we can predict whether a patient will be classified as M or B based on splitting our data into a training and test set. Secondly, we can also integrate classification methods along with clustering our data on other variables other than PCA. For example, how would clustering look on perhaps 2 variables of interest? And finally, we can also consider other statistical methods, such as logistic regression, as another way to predict a patient's status, or using multiple linear regression to numerically predict another variable of interest. That concludes our presentation. Thank you for listening, and we would love to hear your thoughts in the discussion board.